Before you start, Adam, you feel like you got?
Yeah, I think we have everyone here we need. Maybe just a quick go around so everyone knows who everyone is. We got a lot of new faces, and maybe what your role, especially for Stanford, what your role will be with the maintenance.
I'm Steve with San Jose Boiler. I'll be conducting the training class. Nice to meet you.
I'm Tony with HVAC here at Stanford.
Mark with HVAC. Adam with TPM.
Nolan with Whiting Turner.
Jason Whiting Turner.
CJ Whiting Turner.
Fred from HVAC.
Okay.
Turner at DEC.
Nice to meet you all. Okay, so what I like to do with these training classes is, you can interrupt me at any time and ask any questions, but I kind of like to start where it all starts. So where water comes in, and then where it goes from there. So water actually comes in on this 3/4 inch galvanized pipe here. And actually, where is it? Let me rephrase that. Coming in this way here. Oh, I'm sorry. It must be coming in through this way here. And it goes into a modulated feed valve. And you have a bypass around it. The only reason for the bypass around this valve is if something were to go wrong with this valve and you needed to manually keep the system online, you can just throttle this globe valve down here just to get it by until you fix the problem. So this modulated feed valve is controlled by this controller here. So this controller is a Honeywell T775, and what it does is it takes a sample from a pressure transmitter, so it's measuring the weight of the water in inches of water column, sending the signal to the T775 to tell it where the water level should be. Works on a 4 to 20 milliamp principle. Then this sends a signal to this modulated feed valve to tell it how far open it should be or how far closed it should be. When the water level is at its normal level, which is typically about 50% of the tank, it'll be closed all the way. My guess on this system is that because theoretically this is pretty much of a closed loop system, you're not bringing in a whole lot of fresh water. It's pretty much just steam goes out, heats the radiators, turns into condensate, goes to the condensate transfer unit, gets pumped back to the deaerator. You're not really going to be taking out a lot of fresh water. So I don't expect this to be cycling much. Other than evaporation losses, you'll have some evaporation losses, but very minimal. What I like to do too is discuss briefly the purpose of a deaerator. Every steam boiler needs to have a boiler feed system. The boiler feed system could be open to atmosphere, or it can be pressurized. When it's pressurized, it's considered a deaerator. And the advantage to having a deaerator versus a non-pressurized, just an open to atmosphere tank is you can run at a higher temperature. So the higher the temperature in this tank of the water, because it's under pressure, the less oxygen you have. That can damage the boiler. So higher temperature, less oxygen, hence the deaerator. Whereas if you had an open atmosphere boiler feed system, because you're open atmosphere, you can only get to 212 before you're boiling, but your pumps wouldn't be able to pump with that high a temperature. So these deaerators run anywhere from 212 to 220, 230, and the pumps will still pump to the boiler. And that's the most efficient way to do it. They're more expensive, but they're well worth their weight. You don't have to use as much chemical. You don't have as much oxygen to pit the boiler and potentially damage the boiler. So the way we heat it is there's a steam line right here that comes off of the main steam header. It gets injected into a spray head and goes down into the deaerator. So you have steam mixing with water and potentially condensate return coming from, I think you have a condensate return transfer pump in the other building there. Mixes together and goes into the deaerator, reduces the oxygen levels. So we talked about water level. Steam control is based on temperature here. So you have a temperature sensor inside the tank, and that goes to this T775, and that's what controls what temperature we want to maintain in the tank. We obviously don't want to get too hot. 220 degrees is typically a deaerator target. You have two pumps. They're sized for complete redundancy. So you don't need the 2 pumps, but if one were to malfunction, it automatically flips over to the backup pump.
Can I stop you, Steve, for a second?
Yes.
So water level, 2 different sensors. One on the left, water level looks good. It's at 52%. The temperature right now shows 187.
Mm-hmm.
Is that too low? What should be happening?
Depends on your load right now.
Okay.
Like if you don't have much of a load, and it's but when you're under a heavy load, then it'll go up. I'd have to actually check the set point, which I'll do to see what it's set for.
Yep.
But most Deaerators run at about 220, 212 to 220.
So are these accessible, or are we going to need code data on that or anything?
No, these are off the shelf. You can buy these anywhere, and you just have to. We have program sheets, which they're inside the O&M manual. So, and if you don't, if you order it through us, which would come from Parker Boiler, then it'll come pre-programmed. But if not, there's a program sheet, and anybody can do it. It's not proprietary.
Okay, this is, we measure the water level, we control it, and we modulate it.
Correct.
We measure the temperature, we control it, and what do we modulate?
There should be a steam control valve. Are you sure? Right here. I'm sorry. That's. I'm glad you pointed that out.
Okay, and there's the valve we modulate. All right.
And before I forget, something that's important that we'd have to look at the owner's manual to find out, but I think this is an anode. It looks like just a plug, but I think it's an anode. So when you guys do your preventative maintenance, you want to replace the anodes.
It is.
Is it, Mark?
Yes, sir.
Okay, good. So you might want to label that anode, just so you know, because otherwise it'll get neglected. You all know what an anode is to help prevent the corrosion. Okay. So the pumps are centrifugal multi-stage pumps. Again, you have complete redundancy, and it also alternates every time it flips between pumps to divide the wear and tear. You should have pump strainers. We're going that way. Pump strainers here. There's one main strainer. Or they're insulated over, I'm not sure, but there should be typically a pump strainer on the inlet of the pump.
Hey, Mark?
I have to look at the drawing on that.
You got a strainer on the inlet of the pump here? Is there a strainer hidden underneath insulation or something?
I'd have to go look at the drawings.
Okay.
Thank you.
It's a factory set point based on a measurement of inches of water column. So they'll take the level from here to down here. You don't have to touch it. You don't ever have to touch it. No. It's once the only time you ever have to touch it is like, let's say you do a preventative maintenance on this tank and you drain it. This line has to be primed because it's like a U-tube, right? So if you lose the prime, it's not going to know if you have any water in there or not, and it's going to, tell it what it shouldn't be telling. So it has to be primed. But that's only if you drain the tank, and actually it's probably not even that, because if you drain it, depending on, you might have to. If you drain this leg right here and this leg goes dry, you have these valves here. But you can fill it. See that plug right up there? You can take that plug off and you can fill it manually. So you've got your temperature gauge, you've got your safety relief valve. There should be an overflow trap right down here, steam trap. You've got isolation valves everywhere, obviously. You've got another bimetal thermometer here and your pressure gauge there. And then, so what happens is you have a common feed line off the discharge of the pumps, and it goes to the boiler in the back here. You can't really see it, but it really is just going in. There's a solenoid valve that's 120 volts. So whenever the boiler's calling for water, not only will it energize the pump, but it'll also open up the solenoid valve to allow water to go in. We like to use these solenoid valves because normally you have check valves on the discharge of the pumps, but what happens is sometimes the check valves, they leak, they don't seat 100%, so we get steam that comes back from the boiler, and it works its way back into the deaerator, and it overpressurizes the deaerator. So the solenoid valve is, we typically use that as a standard to prevent that from happening.
What should the max pressure of the deaerator be?
The safety relief valve is set for 15 psi. Deaerators can be anywhere from 0 to 5 psi, sometimes 8 psi. Any questions on the deaerator before I
Different gauge.
go over to the boiler? maybe we should discuss the panel a little bit. So you've got a high water alarm and you've got a low water alarm. So obviously high water, like let's say the pumps aren't working for whatever reason, the three-phase voltage gets interrupted or something happens. You're going to get high water alarm. That alarm is going to close the set of contacts to go to the delta V. Is that what you guys call it? Okay. So it'll close the set of alarms, go to the delta V. Same with the low. So like let's say city water got interrupted. The boiler will actually still run for a while until you guys evaporate water, because again, you're not bringing in a whole lot of fresh water. But if it goes on low water, it won't allow the pumps to run. It'll protect the pumps, and it'll also go to the delta V. So pump 1, HOA switches, pump 2, pretty standard. Alarm silence button, and this is alarm with a slide volume on it for high water or low water. And then pump selector. Steam valve. So that's your steam shutoff valve for the modulated steam valve.
Does that pump selector override the automatic lead lag?
Yes.
Okay, so right now we're only on pump 1.
Pump 1, pump 2, pump. It's which one is the lead? Yeah.
Okay.
Yeah.
Can we look inside the cabinet? So that's steam,
We can.
This is normal operation right now?
Yes.
So that's
Open the cabinet for him?
What's that?
Can you open the cabinet for him?
Oh, I don't. Yeah, that's interesting. Hey, Mark.
Yes?
When Marty was here on the startup, he pressurized it, right? It was on and running.
Yes.
Anybody turn this off? Maybe that's why there's no pressure.
Well, the GE guy was doing some water samples.
Let's let that work for a while. Is the isolation valve on?
You want to look? You want to look inside? Yeah, we'll see what.
This is all I got. Here, you got something?
You got it.
You should all have it.
Oh, that's nice.
Give you something for
Yeah.
Christmas or sometime.
Yeah.
So disconnect, circuit breakers, relays for the logic for the flip-flopping on the lead lag, motor starters for overloads. They're all breakers. And your step-down transformer for your control voltage 220.
I appreciate it.
And honestly, I don't know what that is. It's a power supply. Input 120 to 240. Output 24. So it's just a step-down transformer 24 volts.
DC. All right, well.
And this is already tied into the Delta V then. We're ready.
I'm not sure. I know that there's one relay for loss of power, because Stanford wanted loss of power relay. So I don't know if that's been tied in yet. We're coming back on Tuesday.
We're
to
tied into
finalize
Delta
that.
V right now, right?
I'm still
Yeah.
missing
My guy's scheduled to be out on Tuesday.
Okay. They're coming back on Tuesday to make sure that's all set up.
Okay.
So the loss of power, what's going to happen, I guess, is we're going to take the secondary side of the control voltage. So you got, 480, is that what you have here coming in?
No, we're taking the 120. And then if somebody pulls the power, it's just gonna keep us the relay energized.
And it'll send a
So if
signal.
we know somebody shuts the power off, walks away from it, or we just lose power,
It'll
then
send
we
the
get an
delta V
alarm.
signal.
And then I'll have an alarm here on the pressure. I have a start command. I have a run status, and then I'm supposed to have a high-low alarm.
Are you just going to use one general alarm for anything that goes on here on the pad, or you
There's
got
a
separate
general
alarms?
alarm that comes off of this control.
How about our high-low water? We got separate
There's a
alarms?
high-low on that.
But
Yeah,
they're all tied into one series.
But they
circuit.
haven't tied them in yet. They're all individual points.
They're individual points.
Now my big question is, I've got the plumbers as call-out. Who's gonna be the call-out, now that I see all you guys here?
Boiler,
So Because, yeah, I mean, when this thing fails, are you guys gonna get called out? Or the plumbing shop?
Plumber get leak, water leak, the plumber. When they rent the plumber now.
It's usually the controls.
I don't have a leak. So that's gonna be a general.
Don't call a plumber.
Call the HVAC shop, and if there is a leak, then they'll call the plumbing shop.
Call Jesse.
Or call the plumbers, they can call us.
Well, right now I have them installed out, so I'll change that to HVAC call.
Yeah, the boiler is out, not plumber. They have a leak.
Because there is no leak around.
But we call plumber call us, and now we have two guys come out.
I'll let you guys fight about that. All right, so let's go to the boiler. Well, before we go over to the front of the boiler, this is the water column. By code now, ASME code used to require that the boiler have 3 tricocks, what they call here, because years ago, before boilers were actually automated and pumps automatically came on, operators used to physically have to open up the water column, and the bottom one they'd open it'd be water, the middle one they'd open it'd be steam and water, the top one they'd open it'd be steam. That's how they knew where the water level was. That's kind of like not really required anymore, but for whatever reason they're requiring just the one. Because you have the water glass here that tells you what the water level is. The water glass, the fixture set, this is a 1/2-inch fixture set, and if for whatever reason, and it does happen occasionally, but if the water glass breaks for whatever reason, a lot of times near the nut here, it'll get etched just from years of service, and then it might break, and if it does, there's a little ball check in there, so if there's pressure, the ball check will seat, and it won't let steam just go all over the place. That's the way it's supposed to work. And if it does leak, you can still operate. All you have to do is just turn this off, and then go get a new glass, put the new glass on, and then turn it on. So you don't, it's safe to do a complete shutdown if you feel that's necessary, but if you're turning this off and you don't see any steam coming out or anything, you're safe. So that's what this is. And then this is what we call your equalizing line here. So you've got a pipe, 1-inch pipe that goes into the top of the steam drum. You got your water column. You've got this pipe that goes into the downcomer on the boiler. So again, it's basically like the principle of a YouTube design, like on here. It's just what's happening here is what's happening in the boiler. And so this device here has a series of probes in here, I think 4 probes. So one probe is like a low water probe, so if the water gets too low, it'll turn the boiler off. There's a secondary probe in a separate location. So if the water level gets too low, even beyond the low water probe on here, there's one that's a little lower, and we intentionally want that in a separate location for a good reason. Because let's say hypothetically, this pipe were to get plugged up down here. Well, this might say, okay, boiler's happy, and we're full of water, and it's firing. Well, the boiler could be melting, and just molten steel, so we obviously don't want that. So we have a secondary probe in a different location that is a manual reset, so if the water level continues to drop down below the lowest permissible, it'll sound an alarm, shut off the boiler, will not fire unless you manually reset it. We'll go over that in a minute. But, so it's important to know, there's 2 low water cutoffs per Title 8 Cal Code. One is an automatic reset, which is the one in here. The secondary one in a different location is a manual reset. And then you have start-stop probes for your pump in here as well. And then you have a high water probe. So you have a lot of safety functionality here, and all of the safeties on this boiler are tied into one relay. So if anything goes wrong, that one relay will close the set of contacts and go to the delta feed. Okay. So, and it'll sound audible alarm too. So let's go ahead and go over the side here. So this boiler is a low NOx boiler, which is required by Deaerator Air Quality Management District now. All boilers need to be low NOx. So I'm going to go ahead and turn it off for a minute just to... You have a series of switches on the top. The one on the far left is control power. So that's the 120 volt power that powers this control panel. You've got this switch that I just turned off right now. This is burner switch. I typically recommend when you need to turn the boiler off, or like I just did, I wanted to be able to hear each other, or if you just want to do something, but you still want the water level to work and be where it should be, just turn the burner switch off. If you're ever going to turn the boiler off at night, you're doing some gas shutdown work, anything, just turn the burner switch off. That way the water level still goes where it should be. And because if you turn off the main power, what's going to happen is the boiler's going to cool down, it's going to evaporate, and all the steam is going to continue to go out to the plant, and the boiler will go off on low water because you turned off the logic for the pump start-stop signal. So I always say turn off the burner switch mainly if you're going to turn it off on a regular basis, or is this going to run 24/7?
You better keep them 24/7 when you
Are you going to run it in the summer?
No.
It'll get turned off for a season.
Well, if you're going to turn it off long term, then go ahead and turn off both switches. But like if you're going to turn it off for the week, a lot of people turn them off on Friday, turn it back on Monday, that kind of thing. Just cycle the burner switch. If you open this panel, it will kill the power to the control circuit because there's a door safety switch up on the top right-hand corner, which I'm going to show you. It's right here. But you can bypass it if you need to do some troubleshooting by wiggling it and pulling it. So now, because a lot of times we might have a problem with, like, let's say a water level control, but we can't see it in action and we want to see it happen. So a lot of times what I'll do as a service technician, my background is a service tech, I'll come out and I'll pull it out and I'll leave the panel open, put these covers on. If you guys say, hey, I think I have a problem with one of these boards because it's going off on low water cutoff, then I'll say leave it open for 24 hours, whatever. Next time it goes on alarm, walk up to it, tell me what LEDs are on, tell me what are not. Then we know where to go. But if you cycle the power, it's going to start all over again and you won't know. Yeah. So I'll go through the panel. These two circuit boards here are what we call dual function controls. So there's a label and a sticker for what they do. So this one, for example, is low water. So that's your low water control. The automatic reset, the one that's in the water column. Okay. The secondary low water is on this side right here. So if you kind of cut this control in half, it does two things. This one, secondary low water, it has a manual reset button, which is right here. So if the boiler were to, the water level in the boiler were to get below the second probe, this one would trip, and the boiler would not fire unless you manually reset this. This side of the control is your pump control. So it tells your pump when to start, stop. And this one typically is high water, if high water is used. This is a TDR relay. That relay should never be touched. That's part of the low NOx premix system for the pre-purge and the logic behind what we have to do before we can allow it to fire. This control here is a manual reset control. If the pressure were to get too high, they call it manual reset high limit. So there's a red button here that requires resetting if the pressure would ever get too high. That should never really happen. I mean, unless somebody adjusts it, it's malfunctioning, or a lot of times if somebody feeds the boiler initially the first time and it builds up a lot of air and it squeezes the air pressure and it fakes it out, it's not really steam, it's air pressure, so you might have to manually reset that on initial startup.
You get how many PSI?
15. This is a 15 PSI boiler. So, the definition between high pressure and low pressure is 15 PSI. So this is a low pressure steam boiler. But because it's a 15 PSI boiler, doesn't mean you can run at 15 PSI. You have to run it 10% below the safety relief valve setting. So 13.5 PSI max. So this is an operating control as well. These really are not going to be cycled. These are kind of redundant. This is the operating control. Okay? It's another Honeywell T775 just like those. They're not all the same. I think this one has a different model number. So those two might be the same, but this one's different. Honeywell T775s are offered in different series and model numbers. This has a pressure transducer, which is right here, measuring the pressure in the boiler. So right now we're at 3.5 PSI. I don't know what it's set for, but it's actually pretty intuitive. If you want to change anything, you can hit menu, and then it goes automatically to program, and it's telling you to go that way with the arrow. And then you have your modulating signal. When we tell it to modulate down, you can go down to relay 1. And you have your set point, it's telling you to go that way on set point. So it's set for 10 psi, that's what the pressure is. And then if you ever just want to get out of it, just hit home. It's a pretty simple control. I don't think you guys are really going to be changing it much. For the most part, it'll probably just be set for 10 psi and that's it. One thing I want to point out about Parker Boiler's wiring diagram, which is really nice, is everything is from top to bottom. So if you're troubleshooting and you don't know what's going on, start at the switch. Okay? So you got your main burner switch, and then just work your way down. And it tells you, this depicts this control, this depicts this control, and it literally goes all the way down straight through a series of switches until it gets to the flame safeguard system. So you can literally just go boom, 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 boom until you find the break. So it's a really intuitive and easy wiring ladder diagram to follow to figure out where the problem is.
What are the 4 wires that are not connected?
Yeah.
That's going to happen on Tuesday. Yeah. The relays, you'll see relays here. There's a relay for start-stop. There's a relay for status. There's a relay for alarm. There's also a 4 to 20 milliamp signal going out to tell the delta V what the pressure is at the boiler. And it's all on this schematic here. Everything here. These relays, those are all the relays. So got a lot of functionality here. Any questions before I close the panel? Okay, so this switch here, you guys really should never touch. It's for us, for tuning. It's a low fire hold switch. So when it's to the right, it allows it to go to full modulation into high fire. When it's to the left, it tells it to go into low fire. Because when we do our combustion tuning, we have to tune it in low first, and then we tune it in high. So we have to force it to low. So this is really just for us.
Are those labeled at all? Are they labeled on the top or no?
They're labeled on the top.
Okay.
Yeah, there's stickers on the top. And then this too is from top to bottom. So, control power on, level safe, limit safe. Excuse me. A limit is anything. It's the manual reset high limit, it's the automatic high limit, it's the operating control, it's any of your switches or safeties. So it's saying, okay, limits are safe, I'm ready to fire, but it's not firing because I have the burner switch off. And this is pilot on, and this is burner on. So whenever you have flame, this one will come on. So you guys familiar with the flame safeguard control, the fire eye? The fire eye control is basically the brains of the flame safety circuit. So it will look in the combustion chamber to see if there's flame in there when there shouldn't be flame in there, and vice versa. It'll look in there when there should be flame, and if there's not, then it locks out. It has a reset too. So it monitors your pilot, it monitors your flame signal, it tells the blower to come on, and so it's basically, its job is the flame circuitry. There is an optional display module that holds some fault diagnostics. If you wanted to plug it in here, you can take this cover off. And there's an RJ45 connector here. So the optional display module, you plug it in and it saves the last 6 faults so you can see what the faults are. If you wanted to see what the flame signal is, you feel like it's intermittently flame failing, you want to test the pilot, you can see the flame signal. But if you don't have that, which I don't think you really need it unless you had a multitude of these controls throughout the campus, so then you just have one and plug it into each boiler. But it also gives you some flashing indications. So like let's say the boiler flame fails because there's no gas, then it'll lock out, and like let's say these 2 lights are flashing, so the lights are right here, so the 2 outer lights would be this code right here, so that tells you, line frequency noise or flame failure for PTFI, which is pilot trial for ignition. It basically is just like a simple way to see why it failed in flashing lights. This is modular too, so like you have the program module, which is this device here that pulls out, you have the amplifier that pulls out, and then you have the chassis. So if you guys think you're having a problem with this, like let's say when the warranty's up, because for 1 year everything parts and labor is included, so just call us if it's within a year. After a year, if you're having problems, don't just go buy a new control, bring us the control. We have a counter, we plug the control into a simulator and we test it, so you don't have to spend $500 if you don't need the control. we'll tell you if it's wrong or if it's bad. And then this is a variable frequency drive. So what happens is this boiler, it's full modulation. So the Honeywell T775 monitors the steam pressure in the boiler. And we tell it, okay, you know, we want you to turn off at 10 psi, but like let's say at 7 psi, we want you to start driving down into low fire. Fully adjustable. We could say at 5 psi, whatever you want, in order to avoid short cycling. But let's hypothetically say it's 5 psi. So at 5 psi, let's say the pressure's rising from 0 and it gets to 5, then it starts to modulate down. This sends a 4 to 20 signal to the variable frequency drive. The variable frequency drive sends a signal to the blower motor. So 60 hertz is high fire, and usually 20 to 30-ish, depending on the system, is low fire. So that's how that works. The nice thing about this is this has a filter. And the way this system works is if that filter were to get dirty, it doesn't mess up your combustion at all. Whereas a lot of boilers, if the filter's dirty, then you're going to go fuel rich. You're not going to go fuel rich on this because this works on a ratio principle. So what happens is this valve here, the Siemens valve, has an air sensing line, and the air sensing line comes off of it, and it's monitoring the discharge pressure of the blower. So what happens is the gas follows the air. So you got more pressure on your air, you got more gas, and vice versa. You got not a whole lot of pressure, like let's say you put a bag over that, you're not going to have any gas. So it works in direct ratio. So good and bad. Good because you don't set up the firebox, you don't damage the burner, you don't do any of that. Bad because you might be running a 90 horsepower boiler at 40 horsepower because it's derated automatically when it's dirty. So keep the filter clean. Probably want to order a spare, you know, have one available, especially if they use leaf blowers around here. That's a big thing that gets them dirty.
That's not a washable filter?
It is. It's just a KN filter, just like on an automobile.
Oh,
yeah.
Good, because with that construction right now, it's probably going to get plugged quick.
Yeah. And I highly recommend, I mean, you can run it without the filter for maybe a day or something, but don't do it for longer than that, because then what happens, it'll get into the burners. And the burners are a metal fiber mesh burner. They're like, you probably have, I don't know, maybe 20, maybe 40 in there. There's a lot of burners in there. They're like $800 each. So you don't want to ruin them by getting them dirty. They'll last forever if they, you know, they don't see, if that filter's there, you're fine.
Is that an item you have on the shelf down at the San Jose boiler?
Most of the time. If not, Parker Boilers in Los Angeles, one day.
One day.
Yeah. Anything here on this system, one day. They're in Los Angeles. So for the most part, we stock almost everything. We have the burners in stock. We have the blower motor in stock. A lot of the filters in stock. The VFDs, the Fire Eye. I mean, maybe some stuff on the Deaerator we might not have, but for the most part, we stock pretty good inventory. And then, so let's just go over the sequence of operation real quick. You're at 0 psi. Turn on your switch. Turn on your burner switch. Blower comes on, ramps up slowly. You'll see the hertz go up. Goes up to what we set it for on pre-purge. So your pilot just turned on. Your pilot's going to prove when the flame light comes on, that means you've got a flame on your pilot. Your main just came on, so it's firing up, still ramping into high. We got a half a pound on the boiler right now. You're in high fire. Don't make the mistake that 60 hertz is high fire. High fire is what we set, what we tell it to be, based on pressure readings of the manifold and what the factory wants. Every job is different. You might have 100 feet of stack on it. You might have 10 feet of stack. Everything affects the fire rate. So that's your high fire, and then that's what low fire is going to sound like. Most of the time I'm thinking this thing's going to be running in low. It's going to be not much of a load. It's a pretty consistent load. You know, it's not like when you first turn it on, if the building's cold, obviously you're going to be ramped up in the high fire. But with the building the way it is, it's probably just going to come on and off and low and maybe hover at 25%, something like that. So that's what low fire sounds like. Pretty quiet, so I don't think you're getting any complaints on noise. Okay, let's talk about manual resets. I mentioned this one. I mentioned the one inside, the manual reset high limit if the steam pressure gets too high. I mentioned the flame safeguard, the brains of the flame circuitry. You've got a gas pressure switch here. It's labeled. It's a high gas pressure switch. You've got a low gas pressure switch, which you can't see because it's behind this valve. You've got a flame rollout switch, which is this one right here. This is if something goes wrong, like let's say the flue or the chimney were to get blocked for whatever reason, and the heat is staying in the boiler and it's coming out and it's rolling out into this cabinet. This is a thermal disk sensor. So at 180 to 220 degrees, I forget what the exact setting is, it'll trip. So again, if that happens, you're not going to know it, right? So the only way to know it, either you're pushing buttons or you're opening up the panel and you're looking at the wiring schematic and you're going from top to bottom. My advice is go from top to bottom, document it, and call us and let us know. Because, you know, if you guys work on boilers very often, obviously, so you know what you're doing. But if we have a warranty issue, we need feedback. So if, let's say I have a defective switch that's tripping too early, I got to know because I got to replace it. So if you want to document that.
What about on our little VFD up here? We lose that. Do we have to have you come out and program it?
You don't. There's a program sheet right here.
Oh, beautiful.
We stock the VFDs. Anybody who has AC Tech, it's not a proprietary VFD. So here's the program sheet. You just go to each perimeter and you put it in. I don't think the password is on here, but we can give you the password if you call us. I think it's 225, but they're very simplistic. The other thing is, more than likely you won't have to do anything but take out this EEPROM chip. Just take out the chip, put the new VFD in, pop the chip in, and it's already pre-programmed.
Oh, okay, so it'll automatically download.
Unless it gets wet. If the chip gets wet, then all bets are off. That's one good thing about Parker Boiler. They don't do a whole lot of proprietary controls. It's pretty much off-the-shelf stuff. So, okay, before I get into preventative maintenance, do you guys have any questions on the operation of what we just discussed?
The enclosure of our VFD and where you put the cover bike with maybe all the eaves and things.
No, we always leave it. I don't know why the cover is off, but it's always closed.
I know, but we don't have a problem with overheating then?
Oh, no. No, not at all. I don't think I've ever lost one of these AC Tech drives. We've been using them for probably 10, 15 years.
You can give me like a 10-pound plexiglass. You play that so we can see the VFD.
I guess we can always.
You can if you want. I mean, it's all that's going to tell you is the hertz in your firing rate.
Yeah, I'd like to see one.
You like to see it? Yeah. I mean, you can. You can leave it off, actually, too, because this is a weather protected. You know, you're not going to get rain in here unless these doors are off. But you could, yeah, you feel free to put a plexiglass cover on there.
So it really only has the high and low.
Our share of problems.
If it's high or low fire, I'm only going to see two different readings here. Either I'm at low.
No, and you'll see anything in between
Okay.
when I release it to modulation.
I got you. Okay, I see. Okay.
Yeah.
Sure. Anything from low to high.
Yeah. Usually it's like 20 to 45, and then anything in there.
Gotcha.
If you're going to shut the boiler off for the season, go ahead and turn off the control switch, that one there, and then I would go ahead and isolate the natural gas just because, maybe lock it out for the season, that's fine. The Deaerator, it's pretty self-explanatory, just turn everything to off and manually turn off all your isolation valves. Whether you want to drain it or not, draining it probably would be a good idea because, you're going to have chemicals going into there. Yeah, you'll have sulfites, which are kind of aggressive. So if you have sulfites aren't as aggressive as the phosphates that are going in the boiler, but depending on the layup time, how long you're going to be, you may want to drain it down. Like phosphate sitting in a boiler for a long time is probably not good. You probably want to drain the boiler down for your summer season.
Do we have a quick bar on the gas line?
Sure. So gas comes in on this galvanized 2-inch pipe, comes in this way. This is your manual isolation valve here. You have a, 1/8 take off going that way. That goes to your pilot gas train. So your pilot gas train consists of a strainer, that brass strainer, a regulator, and then a 120 volt solenoid gas valve. That's your pilot train. And then your main gas train consists of the SKP, they call it, the Siemens. And it has a secondary solenoid valve. And I don't know if you guys know this, but the reason you have two is because we're in California. California requires two of everything. 2 low water cutoffs, 2 main gas valves, 2 pressure controls. So there's a code called Title 8, fired pressure vessels. And because boilers used to blow up prior to 1950, they implemented this code that said, no, we're going to have redundancy all over the place. So that's why we have 2 of everything in California. Let's see. Okay, that's it for in here. Preventative maintenance. I'm going to suggest that you guys probably do your PMs before the start of a season is going to be better. Because if you do it like when you turn the boiler off, you know, you might have leaf blowers and everything that's just getting shit dirty. So, I'm sorry, getting stuff dirty. So preventative maintenance, what that consists of is, let's go over on this side. You're going to want to take the cover off of this control here. This is the water level controller. And there's a series of what appear to be spark plugs. They're just level probes, porcelain probes with stainless steel 1/4-inch rods. And you're going to want to take them out. Take them out one at a time. Okay? Don't take them all out because then you won't know which one, how long it was, where it went. Even though the wiring schematic is labeled A, B, C, D, and there's stampings on here, A, B, C, D, after 5 years of operation, this one gets a little fuzzy and you can't see it. So just do one at a time, you can't go wrong. Take it out, take some memory cloth, clean the stainless steel probe, put it back. You can reuse the gasket that's on it, it's a copper gasket. Put it back, do the next one, so on and so forth. And then there's another one up on top of the boiler somewhere. I don't know if it's in the front or in the back. That's a single probe.
Oh, that's good. Yeah.
So that's that. That's really important. And a lot of times when we have water level problems, and it's not unusual to have water level problems after an initial startup, because a lot of times we'll get some coating from the manufacturing of the boiler or from new chemicals or whatever, and it gets like a little slimy coating on it, and it causes the pump to never shut off, or it causes the boiler to go off on low water when it's really not a low water condition. It's just that you're not getting good conductivity on the 1/4-inch probe, so we might have to clean them if that happens. But I know Therma, they did a boil out chemical, so a lot of it should be cleaned anyway. So this is the combustion chamber door that comes off. You just take and loosen these up, open them up, pull it out. In the boiler, you have, you guys want to open it? Door?
Yeah.
Okay. I might need some help. Anybody have a Lebanon?
Monkey bars.
The screwdriver. Fred has a letter. That's good.
It's better.
Just the screwdriver. I'm not water treatment. I'm
They're giving us
nature.
away.
Are they really?
Yeah, just with a piece of paper. You know what you
Yeah,
told me
and
yesterday?
a signature,
That's
that's
what
it.
he told me yesterday. They're giving those away.
511 mix, no, I got it.
Just with a piece of paper. You were there when he told me that, huh?
Yeah, I guess one week's
I'm going to put this in here. Yeah. Can I get a hand over here?
Sure.
With the contact. Oh. Oh, maybe we didn't mention that after all.
Anybody with a, is there a rag around? It's kind of hot.
Water treatment guy? No rag? I don't have a rag.
Rag or gloves?
Let's put that on that thing.
It's in a mule kit. I'll get it in there. Oh.
While they're getting a rag, the chemicals, probably similar to the rest of your campus, you have sulfites that go into the deaerator, and that's to reduce oxygen scavenger. You have phosphates. Phosphates is a scale cutter. That's what reduces the scale buildup in the boiler. Then you have amines, which goes into the steam system to treat the steam line. It's fun getting back on. So these are tube bundles. You got 1, 2, 3 tube bundles. If you ever had to retube the boiler, which hopefully you don't ever have to, but like let's say the water chemistry went wacky, somebody wasn't blowing down the boiler, that kind of thing, then you might lose a tube bundle. The good thing about this boiler is you don't have to do any welding, you don't have to do any specialized rolling, you don't have to do anything. You break a union here, break a union there, break a union on the other side, slide out the bundle, I make it sound easy but it's heavy, and then put in the new one, line it up, that's a bundle. We always stock these bundles. These are inspection plugs. It's a straight thread, not tapered, and it's 3/4 inch, and the boiler came with a wrench, which is basically a breaker bar, and it came with extra copper O-rings, which are right here between the cap and the boiler itself, and plugs. So you should have at least 10, 20 extra ones already, but they're like $1.50 each or something like that. Anyway, when high pressure steam boilers, inspectors make us open up some that they want on every tube. Low pressure steam boilers, you're not subject to annual inspection by the state, so leave it up to you guys, however many you want to do. I recommend maybe one up here, one down here when you do your preventative maintenance, just to see what's going on in the bundles. You can only see the straight run. After the first bend, you're not going to see anything anyway, but usually if you're going to get any buildup, it's down here. So these are your burners. The expensive ones I was telling you about. So those are metal fiber mesh burners. So I'm going to go ahead and cycle it so you can see it fire up. Low gas pressure works. Water level's still low. Epsilon.
Oh, so that's measuring this. Oh, gotcha.
Well, that's well, this.
Oh, we shut it up, did you?
What's it? No,
No,
it's not that one.